Assalamualaikum. We are going to discuss 7.6, which is probability distribution function. The probability distribution is the listing of all possible outcomes of an experiment and the corresponding probability. Probability distribution of discrete can be represented using table, graph, or formula. These are the two requirements for probability distribution function of discrete random variable. The probability values must be between 0 and 1, including 0 or including 1. And the second characteristic is the summations of probability x is equal to 1. Look at example 21. Each of the following table lists certain value of x and the probability. Determine whether or not each table represents a valid probability distribution. Okay, if you look at this probability distribution, it consists of probability with negative value. Probability cannot be negative, therefore this is not a probability distribution. In example B, the probability, if you take all the probabilities, the total is 0.95. Therefore, this is not a probability distribution. And for the third example, if you take the probabilities and add them up, it is equal to 1. Therefore, it is a probability distribution. Okay, so this is the solution and you can refer to this slide. So as we said just now, A is not probability distribution. Second one, B is not a probability distribution since the sum of P is not equal to 1. And C is a probability distribution because the sum of probabilities for all value of x is equal to 1. Now let's take a look at example 22. A company is planning to select 3 applicants to fill up 3 vacant positions. Suppose the probability that a female applicant being selected is 0.4, while the male applicant being selected is 0.6. Assuming an applicants to be selected are independent for each position. Find the probability distribution for x, the number of female applicants selected during the final interview. We can use a tree diagram to solve this problem. Okay, we have the first trial, whether we get a female or male. Second trial, whether we get female or male. And the third trial, whether we get female or male. Right, we continue, draw the tree diagrams as shown here. First, we get female, female, female. The second outcome is female, female, male. The third outcome is female, male, female, and so on. So altogether, there are 8 outcomes. So from these outcomes, we list down in a form of set and we call it as a sample space. Alright, next we let x to be the number of females selected in the final interview. So the possible value of x is 0, 1, 2, or 3. To find probability x equals to 0, meaning probability all 3 are males, you're going to have to multiply 0.6 times 0.6 times 0.6. So the value is 0.216. And then to find the probability x equals to 1, so there are 3 outcomes here. And then you multiply as shown in the slide. And the probability is 0.432. This is when you want to find probability x equals to 2, meaning 2 females. So there are 3 outcomes, and then multiply the probabilities, and the total should be 0.288. And last one, probability X equal to 3 when you choose 3 females, so the probability is 0.064. Alright, you can represent all these values using table as shown here and represent its probabilities. And this is the sketch. Now we look at example 23. A box contains 3 defective bulbs and 3 undefective bulbs. An electrician draws 2 bulbs at random from the box. X is the number of undefective bulbs drawn. Show that X is a discrete random variable. Okay, so our variable X represents the number of undefective bulbs drawn. So the possible values is 0, 1, 2. Okay, let me use U to represent the number of undefective bulbs. D is the number of defective bulbs. We can use a tree diagram to represent the respective question. So the first trial, whether we get an undefective bulbs or defective bulbs, and the second trial, whether we get undefective bulbs or defective bulbs. Again, undefective bulbs and defective bulbs. The first outcomes is UU, second is UD, third is DU, and fourth is DD. So to find the probability X equals to 0, which means both are defective, you will have to multiply 3 over 6 and 2 over 5, which is equal to 1 over 5. To find probability X equals to 1, so there are 2 outcomes, UD and DU, and you multiply all these probabilities and you should get 3 over 5. To get probability 2 undefective, you multiply these 2 probabilities, you should get 1 over 5. Alright, you can summarize all the probabilities using a table shown here. And what you can do, you list down all the values of X and its probabilities. And as you can see here, the total of probabilities is equal to 1. Next, we look at example 24. The random variable X has the following probability distribution. K x squared when X is equals to 1, 2, and 3. K times 7 minus X squared when X is 4, 5, or 6, and 0 otherwise. Determine the value of K. So, to determine the value of K, we know that the summations of all probabilities must equal to 1. So, what we can do, our summations of probability for all values of X is equals to 1. Then we take probability X equals to 1 plus probability X equals to 2 until probability X equals to 6. So when X equals to 1, we take K times 1 square plus K times 4 square plus K times 3 square. When X equals to 4, we substitute in the second function. We have 7 minus 4 square times K, 7 minus 5 square times K, 7 minus 6 square times K. Alright, so you're going to have all these values, which are, when you total it up, you will get 28K and let it equal to 1. Therefore, K is 1 over 28. So, you can substitute back in your function. Next, when you want to find the value of the value of x, probability for x equals to 1, so you're going to get 1 over 28. X equals to 2 is 4 over 28. And this is for x equals to 3, x equals to 4, x equal to 5, and x equal to 6. Okay, and summarize it in the form of table. For question C, find probability x equals to 2. You can directly have the answer from the table, which is 4 over 28. Question D, find probability x equals to 4 plus x equal to 6. So total these two probabilities, you should get 10 over 28. Question E, find probability x equals to 4.5. There is no x equals to 4.5. The probability is 0. And the last one, to find the mode, we look at the highest probability, which is 9 over 8 when x equals to 3, and also when x equals to 4. So the mode of the variable will be 3 and 4.